Hey everyone, welcome back. In this video, I'm going to be talking about weld symbols, what they look like, what they mean, how to identify them on a blueprint, and all the different types of information that will accompany the weld symbols. Stuff like the size of the weld location, what process to use, and even how to prepare your materials. And then we'll talk about how all that together or all of that comes together to create the welding symbol. So there is a difference between weld symbol and welding symbol. So just keep that in mind. So let's go ahead and just hop into it. Here you can see we have 5 different welding joints. They've all been welded up already. And so as a welder or even a fabricator, you're going to come across many different variations of blueprints that are going to tell you information related to whatever project that you're working on. And they're going to give you information like dimensions, the size of the project that you're working on, where to put certain pieces. But the actual information that we need to start looking at are the weld symbols. So that way we know how to actually assemble what is being put together. And in general, the welding symbol is going to give you a lot of different information. It's going to tell you the length of the weld, the size of the weld, where the weld should be located. It's going to tell you if the weld needs any special actions to be taken after the weld has been completed. And it's even going to tell you how to prepare your metal before you start welding. But before we get into all that, let's just focus on the weld symbols and how they come together to create the welding symbol. So what you're looking at right now is an example of a welding symbol, and there's a breakdown that explains every aspect of the welding symbol. And I know that it's a lot to take in. There's a lot of explanations all over the place, and there are arrows pointing all over the place, and it can be a little confusing if you don't know where to start. And that's what I'm going to talk about first. And so when we say welding symbols, I want you to think of a welding symbol as being the complete package of weld symbols and all the information that relates to those welds and to any sort of material preparation that needs to be done for any one location or for any weld or series of welds that the welding symbol happens to be pointing to. And that brings me to the reference line. The reference line is the foundation of each and every welding symbol that you'll ever come across in any blueprint for welding and fabrication. The reference line consists of one horizontal line that has a break in it, which will continue into a second line with a filled-in arrowhead at the very end. So let me go ahead and draw that one more time for you. Now, the information that's going to help us when determining how to create our weld or welds is going to be located on the top part of the reference line or on the bottom part of the reference line, and in some cases, both sides of the reference line. Now, remember how I told you there's a break in that horizontal line which makes up the reference line? This is what's called a leader line. So wherever you see a leader line pointing to something, you want to make sure to follow it all the way back to where it originates to find out what sort of notes or information pertains to the area that it's pointing to. And in this case, the leader line originates from the reference line. And I didn't draw it before, but there's also a tail section to the reference line. And you'll find any sort of additional notes in here that cannot be drawn as a symbol on the reference line. This can be stuff like what type of welding process you're supposed to use, what type of electrode you need to use, or basically any other additional notes that you can possibly think of that cannot be drawn as a symbol. Now, you will encounter cases where the reference line doesn't have a tail section. The tail section is actually optional. So if there are no additional notes that need to be added to the reference line, a lot of times the blueprints will just print the reference line without the tail section. And before moving on, we need to address that the bottom side of the reference line is what we call the arrow side. The top side is what we call the other side. And this is going to be crucial to remember So that way, wherever the reference line happens to be pointing to, you're going to know what welding information pertains to exactly where the line is pointing to. And if we switch back over to the diagram of the welding symbol, if you look right there in the middle of the reference line, you can see in between these brackets on either side, arrow and other, that this is where the weld symbol is going to be located. Now there's one more bit about the reference line that you're going to need to know, but I'm going to wait to explain that until after we get to our first weld symbol. So let's just jump right in. So here I'm giving you a reference line and I'm going to give you a weld symbol. Go ahead and pause the video here and see if you can figure out what type of weld this symbol is describing. If you said fillet weld, then you're correct. The symbol for a fillet weld resembles a right triangle, or a triangle with two sides that are perpendicular that when they meet form a right angle, or a 90-degree angle. Now the second part of this question is, what side is this weld symbol located on the reference line? Go ahead and pause the video here and write down your answer, and then when you write it down, go ahead and resume. If your answer was arrow side, then you're correct. This was just to see if you were paying attention. So remember, the bottom of the reference line is always referred to as arrow side, whereas the top is always referred to as other side. So how would you apply this when given an actual project to work on? Well, let's take a T-joint just to keep it simple. So on a blueprint, if you're given a T-joint and on the reference line you see that there's a fillet weld symbol on the arrow side of the reference line, where do you think the weld would go? In the event that you're given a weld symbol on the arrow side of the reference line, you simply look and see where the reference line is pointing to. So the joint that the arrow is pointing to is going to be where you place the weld. Now let's use this same example, but let's say you have a weld symbol on the other side of the reference line. Now, where does the weld go? Well, we still need to look and see where the reference line is pointing to, and we need to figure out that joint, because the joint that is opposite of where the reference line is pointing to is going to be where the weld goes when you have a weld symbol on the other side of the reference line. All right, one more example. I'm going to stick with the T-joint, and let's say the reference line is now coming in from the opposite direction. So whereas before it was coming in from the right to the left, now it's coming from the left to the right. And let's say I give you a fillet weld symbol on the bottom side of the reference line. Does that change the side significance when it comes to arrow side and other side? What do you think? So when the reference line changes direction, the side significance actually stays the same. If a weld symbol is on the bottom of the reference line, that is still the arrow side. So where the arrow is pointing to is going to be the joint where you place the weld. And if you're given a weld symbol on top of the reference line, that still means other side. So no matter in which direction the reference line is being drawn from, or whether the reference line is pointing up or down, the side significance never changes. Bottom of the reference line is always arrow side. Top of the reference line is always other side. Now, before we get into things like the length of the weld, the size of the weld, and the contour of the weld, we need to understand the different parts of the weld. And I'm going to show you an image here soon, but before that, let's go ahead and get to know some terminology. So with the fillet weld, the various parts include the toes of the weld, the legs, the face, the throat, and the root of the weld. Now, as we look at this image, it's basically a T-joint, and there's a fillet weld on both sides. And then you can see all this information that shows us what the legs are, what the toes are, what the face is, the root, and all the different types of throats. Now, again, this is a lot of information, so let me go ahead and break it down one by one. Let's start with the toes of the weld, since this is one of the more easier parts to identify. So if I give you a T-joint and I draw a fillet weld, The toes are where the fillet weld ends on the parent material. That is where the weld ends and the parent material begins. So you can see that on the bottom side, the weld will start where the two pieces of metal meet, and then there's an obvious end to the weld. Same thing with the top. After understanding what the toes of the weld are, we can then look at what the legs are. If we begin at the very start of the weld, or where the two pieces of material meet, from the very bottom of the weld all the way to where the weld ends, or the toe, the length of that distance is what's called the leg. So there's the leg for both sides of the fillet weld. There's a leg on the bottom side, and there's a leg on the top side. And effectively, when we're dealing with fillet welds, the toes of the welds and the legs of the welds work hand in hand. Now let's talk about the root of the weld. The root of the weld is essentially the bottom of the weld, or where the weld originates, where the two parent materials meet. Now opposite the root of the weld is the face. The face is the very top part of the weld. This is what you actually see after you're done welding. And last but not least, there's the throat of the weld. This is the distance between the root and the face. And there are actually several types of throats, so let's go ahead and get into that next. So as we start talking about the throat of the weld, we need to understand that the fillet weld extends past the surface. This is what we call penetration. And I'm going to go ahead and draw that out for you. So understanding that the weld penetrates past the surface is going to make a couple of these variations of a throat a little easier to understand. All right, so the first throat we're going to talk about is called the theoretical throat. The theoretical throat basically only takes into account the very edges of the parent material, and then if we were to draw a straight line from one toe to the other, essentially creating a right triangle. So at first glance, you can see that the theoretical throat is actually a smaller representation of what the actual size of the weld can be. Up next is the effective throat. This is essentially the theoretical throat, but now we're adding in a little bit of distance to account for penetration. So the effective throat still takes into account drawing a straight line from one toe to the other, but now we're including the penetration at the root of the weld. And last but not least, there is the actual throat. Now the actual throat takes into consideration the entire depth of the weld. So this is the root penetration all the way out to the highest point of the face. Now we have these different variations of throat because we need to take into account inspection methods. When we're visually inspecting welds, we're taking into account the both the effective throat and the actual throat. Now the effective throat is going to tell us bare minimum, what the quality of the weld is and how strong it's going to be. The actual throat allows us to look for even more weld flaws and address them from there. And the theoretical throat, well, that's something that we can kind of think of on the engineering side. So now we know when we have a reference line and it's telling us something like you have a fillet weld and it's to go right there, let's start looking at things like the size of the weld. And so how we tell size is we look for a number directly to the left of the weld symbol. So in this case, I'm going to give you the number 1. And so when we look back on this breakdown of the reference line and we see all the different elements that create the reference line, remember that this is where your weld symbol is going to go. It's either going to be on other side or arrow side. The size of the weld is going to be located just to the left of the weld symbol. And here we have two different items that are to the left of the weld symbol, the symbol S and the symbol E in parentheses. So let's go ahead and start with the first one, the letter E in parentheses, and let's follow this leader line back to its definition. And you'll notice that it says groove weld size. Now, we're dealing with fillet welds. We're not dealing with groove welds just yet. So in this case, the letter E in parentheses doesn't apply. So if you're working with the fillet weld and you see a measurement in parentheses, you should probably ask the engineer if this is what he or she meant in lieu of the weld size. Because believe it or not, sometimes engineers make mistakes. So always be sure to double check. If it's in parentheses, remember that it's for a groove weld. Here, we're dealing with fillet welds. Now that leaves us one other element, the letter S. And so let's go ahead and follow that leader line back to its definition. And so here it starts off with depth of bevel. Now there's also a semicolon there, so it's not just pertaining to the depth of bevel. It also means the size or strength for certain welds. Now in this case, when we're dealing with fillet welds, you can almost always take this number 4 being the size. So you can kind of think of the letter S meaning size. And whenever you're looking at blueprints, you're typically going to see one or two different style of numbers here. You're going to see a fraction or a decimal. Now, the fraction, of course, that leads us back to imperial rule. The decimal can either be in metric or going back to imperial rule. So if you see something like 1.25 and you don't see any kind of indicator after it, like millimeter or centimeter, always assume that it's imperial, meaning 1.25 inches. If it's going to be in the metric system, you're always going to see the abbreviation for millimeters or centimeters coming right after the number. Also, one thing to note here is that you're probably always going to be dealing with sizes under 1 inch. If you ever see something that's over an inch, that probably means that you're in a big production facility and you're dealing with really heavy-duty structural projects like maybe bridge work, building work, anything that's really large and needs to be carried away by a semi truck. But if you're working in a smaller shop, you're probably only going to be dealing with measurements that are under 1 inch. So let's go ahead and let's take it back to the example with the T-joint. So if on a blueprint you see something like 1/4 of an inch for the size of the weld, and here we already have the weld in place, what that 1/4 inch means is that from the root of the weld all the way out to the toes on either side, that distance is going to be 1/4 of an inch. And let's say that you had a fillet weld on the other side and they gave you a different size, let's say 1/2 of an inch. It's going to mean pretty much the same thing. From the root of the weld all the way up the leg to the toes on both sides, this is going to be 1/2 of an inch. So the size of the weld essentially is just the length of the leg. So from the root all the way to the toe of the weld on both sides, top and bottom. Now to move on to the next element, let's take another look back at the symbol elements chart. So we covered mostly everything that would come to the left side of the weld symbol. Now let's start moving over to the right. The very first symbol here is the letter L. Now if we follow this up through the leader line, this tells us that L refers to the length of the weld. So we're going to have information that not only tells us the size of the weld, but now we can have information that tells us just how long our weld needs to be. And just like with the size of the weld, this can either be given to you in inches or it can be given to you in a metric unit of measure. You can see this either as a fraction or you can see it as a decimal. So if you have a number to the right side of the weld symbol, then it's going to be how long your weld needs to be. Now if you don't see any number to the right of the weld symbol, then that means that your weld is to be full length. That is the entire length of the joint that you're welding on according to the blueprint. Here I've got a 3D, well, sort of 3D representation of a T-joint. You'll have to forgive my art skills. They aren't really as good as they used to be. So if we look at the reference line and we take a look at the right side of the fillet weld, you'll notice that there's nothing there. Now, in the event that no number is to the right of the weld symbol, you can go ahead and weld the full length of the joint on the blueprint. But if you do see a number to the right of the weld symbol, in this case, the number 3, your weld is going to extend as far as it takes to get to the 3-inch mark. Just the same as if you were to see 1/2 to the right of the weld symbol, your weld would only extend out to the point where it reaches 1/2 inch in length. And here's an example if you were to see something in the metric system on the right side of the weld symbol. So here we have 5 centimeters. So just like with the previous examples, from start to finish, your weld would only measure 5 centimeters. A question you may have is, where do I start? That's when we need to take a look at the tail section for any notes. And if there isn't a tail section or any notes included, this is where we need to use a little bit of thinking. We need to see if it's rational to start at one end of the joint versus the other. And if we still don't know, it's always good to check with our supervisor or the engineer. Now let's jump back to the weld symbol chart. And you'll notice that between the L and the P, there's a hyphen. So there's kind of a second part to the length of a weld. So if we look at this second symbol, or the letter P, and we followed it up the leader line, we'll see that it stands for pitch, center to center spacing of welds. Now, having the length of a weld specified is one thing, but having the length of a weld accompanied by pitch, that has a different and major change on what the weld is going to look like. So before we get too far, just remember this. If there's only one number specified to the right of the weld symbol, that means the length of the weld, nothing else. If you see two numbers to the right of the weld symbol, and there's a hyphen that separates them, what you have now is length and pitch. When you see length and pitch used with the weld symbol, it's almost always going to be either with fillet welds, spot welds, plug welds, slot welds, and even stud welds. So when we see length and pitch on a reference line, our first idea should be, hey, our weld is not going to be complete from one end of the joint to the opposite end. Our weld is not going to be broken up into several smaller welds. So the length is obviously going to tell us how long each weld needs to be, and the pitch is going to tell us how to space out our welds. So if we go back to our T-joint and our fillet weld on the reference line, let's start with the first number, and here I'm going to give you the number 1. So this is going to indicate that our welds need to be 1 inch in length. Now if I give you a -2, or essentially a 1 and a 2 separated by a hyphen, the number 2 is going to represent our pitch. So how do we measure pitch? Are we going to start measuring 2 inches from the end of our previous weld? Or how are we going to do this? Well, if we think back to what the element chart had showed us, it said that pitch meant the spacing center to center. So what that means is we need to find the middle of our previous weld and then measure from there 2 inches out, and then draw a line down, or draw an imaginary line down, and that's going to be the center of our next weld. So this is going to be a place where we need to do a little bit of math. So if we know that from the center of our first weld to the center of our second weld is going to be 2 inches, we essentially need to divide the length of the weld in half to find out how far to the left and right our weld is going to basically start and end. Well, in this case, the length of our weld is only 1 inch. So that's pretty easy. We know that to either side of the center line is going to be 1/2 inch. And if you want to, you can go ahead and draw a line on your material. That way you can keep track of where you're supposed to start and where you're supposed to end. And here's another example of length and pitch. Here I'm going to give you a length of 3 inches and a pitch of 7 inches. So let's go ahead and start off with our first weld, which is going to be 3 inches long. Next, we're going to find the center point of that weld, and from the center, we're going to measure out 7 inches. This is going to become the center of our next weld. And knowing the center of our next weld, that leaves us in a position to find out how much of the weld is going to go to either side. Well, we know the length of the weld is 3 inches, so all we have to do is cut that in half, which is 1.5, or 1.5. So that means that on either side of that imaginary line that we found, there's going to be 1.5 inches of weld. Now, if you're like me and you're right-handed, how you're going to start your next weld is as follows. you're going to measure out 1.5 inches to the left, and you're going to start your weld until you've completed your 3-inch bead. But if you're left-handed, you're probably going to want to start off 1.5 inches to the right and then weld from right to left. And what I have here are some examples of welds that I did in the shop, and I went ahead and I cut them using a bandsaw so that way you can get the best image possible when I show them to you from a side profile. Right now we're just going to be focusing on these two T-joints. And as I turn them around, you can see that I've welded them on both sides. They're varying welds, that way you can see the difference. And I think I'm going to put this T-joint aside, and we'll start with the one on the right. So as we take a look at the first bead, I welded this using a 6010 electrode and at approximately 90 amps, and you can see that viewing it from the side, there's not much of a profile to look at. And on the opposite side, I used 7018 at approximately 135 amps. And so using this electrode, it gives us a difference in the profile. There's a little bit more buildup than there is with the 6010. And I know you can see a little bit of a space or a gap in between the two plates. This wasn't because of a flaw in my welding. This was actually a flaw in my fit up. You can see that one weld has shorter legs than the other. You can start looking at things like the toes of the weld, the face of the weld. And now when I say the difference of their faces, this is what we're talking about when we mention contour. So if someone ever tells you that your contour needs to be a certain type, whether it's convex, concave, or flat, this is what they're talking about. They're talking about the shape of the face of your weld. And now as I switch over to the second T-joint, you can see one side has multiple passes on it, all of them of which I did with 7018. And then on the other side, there's just a single pass, same thing, 7018, but I used a slightly higher amperage, I think 145 in this case. And so as we look at it from both sides, you can see that there's an obvious difference in the sizes of the welds. So what I'm talking about, sizes of welds, always remember the length of the legs. So you can see that here. And again, with this T-joint, I had a slight mishap in the fit up. So there is a gap between the two plates. So don't put all your focus there. Let's try and focus on the welds. You know, that was a oopsie on my part. And this is all just to kind of give you an idea of what looking at the throat, looking at the legs and the toes would look like in an actual welding setting.